February 1943, across the burning sands of North Africa, a single M4A1 Sherman, marked War Daddy 2, lay abandoned on the battlefield near Tunisia, almost perfectly intact. What the Germans found that day was not a trophy to boast about, but the beginning of a quiet crisis they did not yet understand. Within weeks, under the gray skies of Brandenburg, a sealed railcar stopped at the gates of Kummersdorf, the heart of Germany's armored testing program. When the doors slid open, the captured Sherman rolled out, its olive-drab paint still visible beneath the hastily brushed-on black crosses. To the officers and engineers gathered there, it was nothing more than an American mass-produced machine, something built quickly, in bulk, by factory workers in Detroit. They believed Panther and Tiger represented the future of armored warfare. They believed precision would conquer the battlefield. But the moment the Sherman's engine started, the moment it climbed slopes, endured rough ground, and refused to break down, something subtle shifted inside the proving ground. The notebooks filling with observations no longer held the same confident tone. Kummersdorf would soon reveal a truth the German armored force had never prepared for, that the greatest threat to their tanks was not firepower, but reliability, and that this humble captured Sherman was about to expose the flaw buried deep inside. Across the endless dunes of Tunisia, in the dry wind and fine dust of early 1943, armored warfare was entering a decisive stage, not through sweeping offensives or dramatic breakthroughs, but through small signals, details most soldiers overlooked. The collapse of German confidence in their engineering superiority did not begin with Allied numbers, or American air power, or British artillery. It began with a single tank no one expected to matter. An M4A1 Sherman named War Daddy 2, belonging to Company G, 1st Armored Regiment, 1st Armored Division, had been abandoned during the chaos of the Battle of Sidi Bouzid. The tank remained almost completely intact. For the Germans in North Africa, battlefield trophies were useful, but like many panzer officers of the time, they believed there was nothing to learn from American mass-produced armor. Sherman, to them, represented everything crude about American industry: built fast, built cheap, built in bulk. But war does not care about assumptions, and on that windy afternoon in Tunisia, this Sherman became the seed of a technical shock that would spread all the way to Berlin. A German reconnaissance crew was ordered to test the vehicle on the spot. Many of them had driven Panzer III, Panzer IV, or even Tiger prototypes brought to the desert. They expected the captured Sherman to cough, fail, or stall. Instead, the Continental R975 radial engine started instantly, smooth, steady, without hesitation. One German soldier wrote in his diary, "It feels like a civilian car." He had no idea his comment would foreshadow a crisis inside Germany's armored design philosophy. In early 1943, North Africa was more than a battlefield. It was a laboratory for mechanized warfare. The Germans were being pushed into Tunisia, while the Americans, new to large-scale combat, were deploying thousands of vehicles into the desert for the first time. For some German officers, the Sherman was the tank for the common soldier. Easy to drive, easy to repair, easy to teach. They did not realize that this simplicity was the foundation of America's long-term armored strength. During the German withdrawal, Allied forces captured many German vehicles. But conversely, in the chaos of counterattacks and overrun positions, the Germans seized a handful of intact Shermans. A functional, undamaged Sherman was rare, and therefore precious. War Daddy 2 had traveled hundreds of kilometers in the desert without major maintenance. The Germans took note. Right there at the battlefield, a decision was made. Send the tank to Germany, intact, unmodified, untouched. From that moment, the Sherman became an object of quiet fascination. Orders were strict. Do not tamper with the engine, gearbox, or suspension. Germany wanted to see what American industry truly created. No one knew this Sherman would challenge everything German engineers believed about mechanized warfare. The reconnaissance team drove the tank 350 kilometers to the port of Sfax over 4.5 days. This was more than transportation. It became an accidental endurance test. They crossed sand, rock, loose dunes, and steep slopes in temperatures above 39 degrees Celsius. The result was disturbing: no overheating, no gearbox failures, no broken gears, no maintenance stops, no emergency repairs. German Panther crews of the same era often had to stop every few hours, checking oil, readjusting gear linkages, cooling the Maybach engines. But the Sherman simply ran. One German technician noted as the tank reached Sfax, "We have never built anything that runs this long without complaint." He did not dare say it aloud in front of his superiors, but the whisper was enough. In Berlin, analysts had seen American production numbers: 2,000 tanks a month, then 3,000, then more. But those were abstract figures. They had never touched, tested, or inspected the products of that industrial scale. When War Daddy 2 was loaded onto a cargo ship bound for Europe, the Germans saw something they had not expected. This was not a sloppy, rush vehicle. It was consistent, standardized, and built using manufacturing methods Germany had never mastered. America had what Germany lacked: a massive civilian automotive base, millions of drivers and mechanics trained long before the war, factories capable of true mass production, workers familiar with interchangeable parts, and an industrial system designed for scale and repetition. The Sherman reflected all of that. As the freighter crossed the Mediterranean, German engineers prepared protocols, convinced they would expose American shortcuts and crude workmanship. They did not realize the opposite was about to occur. To the engineers of the German army, Kummersdorf was sacred ground. It was where new designs were born, where Panther prototypes were tortured, where Tiger's flaws were exposed, where ammunition, engines, and transmissions were pushed beyond their limits. German engineering culture lived here. The Sherman arrived with no expectations: a foreign machine, a piece of enemy scrap. The engineers prepared to dissect it, expecting to confirm their belief. American tanks were inferior to Germany's precision machines. But during the initial inspection, their expressions began to shift. When the Sherman rolled off the railcar, engineers gathered with notebooks in hand. They measured the cast hull, examined the rounded armor surfaces, and frowned. Germany lacked the heavy casting capacity to make hulls like this at scale. Their own tanks relied on welded plates, precise but slow to manufacture. A senior engineer wrote, "We cannot cast large shapes with this uniformity." Then they removed the transmission cover. Their frowns deepened. The gearbox was simple, rugged, and forgiving. It did not require microscopic tolerances. It did not demand elite machinists. One engineer whispered, "This is not built for engineers. This is built for mechanics." A silence followed, a heavy, uncomfortable silence. Not admiration, recognition, and fear. German tanks were designed under the philosophy of technical perfection: tight tolerances, minimal acceptable deviation, high precision machining materials requiring skilled labor, complex assemblies requiring expert maintenance. Sherman embodied a different approach. Accept large tolerances for mass production, use proven automotive concepts, allow interchangeable parts across factories, design for rapid repairs with basic tools, place durability above peak performance. For German engineers, this simplicity was almost offensive, until they realized it worked. A transmission that could be removed in a few hours on the Sherman required days on a Panther. Tiger needed specialist crews and equipment just to repair basic components. The truth dawned slowly. America designed tanks the same way it designed automobiles, and that was its greatest strength. Panther engineers had warned since 1942 that the vehicle's powertrain was overstressed. Tiger mechanics struggled constantly with maintenance, but high command demanded firepower and armor above all else. Sherman embodied everything Germany had ignored: reliability, maintainability, consistency, logistics, simplicity under stress. The engineers at Kummersdorf recognized that this was not an inferior machine. It was a smarter one. During the first driving tests, Sherman performed without a single catastrophic failure. Mud tests, slope tests, rough terrain runs, extended driving hours, heat stress trials. No leaks, no overheating, no gear failures. A classified note described it as operational stability at a concerning level. Concerning because it contradicted everything they believed about industrial hierarchy. German tanks were supposed to dominate. Shermans were supposed to fail. But Kummersdorf does not lie. Panther and Tiger, despite their strengths, suffered from fundamental mechanical fragility. Panther final drives lasted 100 to 150 kilometers before failing. Tiger clutches burned during pivot turns. Transmissions required constant adjustments. Drivers needed extensive training simply to avoid damaging the machine. Sherman used robust herringbone gears, resistant to stress, had excellent air filtration in desert environments, used a stable cooling system, could be driven by soldiers with minimal experience, could be repaired rapidly even in field conditions. Firepower was not the decisive factor. Arrival on the battlefield was. By late 1943, German engineers realized the terrible truth. Panther, Tiger, and their entire design philosophy were locked into a dead end. High performance, low reliability, brilliant specifications, catastrophic field longevity. Sherman was not perfect, but it was right. The right philosophy, the right priorities, the right balance for a long war. After months of testing, the verdict was impossible to hide. A classified meeting concluded, the vehicle functions with greater stability under field conditions than our tanks. No one objected. They simply closed their notebooks. Sherman had exposed a flaw buried in the heart of German armored doctrine, a flaw too late to fix. When WW2 rolled through the gates of Kummersdorf in the spring of 1943, it did not look like a weapon destined to shake the foundations of German armored doctrine. It looked ordinary, too ordinary. A squat, rounded tank painted in dull olive drab, now smeared with black crosses applied hurriedly by German hands. But ordinariness, as the engineers would soon learn, was precisely the danger. At the proving grounds, the Sherman was unloaded next to some of Germany's most ambitious armored projects: Panther OSD, Tiger prototypes, experimental transmissions, and future chassis concepts intended to revolutionize mechanized warfare. The men in Kummersdorf had built their careers on confidence, precision, and technical mastery. To them, this American tank was a curiosity, a side experiment. The atmosphere changed the moment they put it to work. Initial trials focused on defining the Sherman's mechanical character. German engineers measured track tension, idler wheel alignment, and suspension response as drivers maneuvered the tank across different terrains. The expectation was simple: push the machine until it revealed its weaknesses. But the weaknesses did not appear, and that absence became the first crack in their confidence. The vertical volet spring suspension, simple by German standards, absorbed impacts cleanly. The tracks maintained reliable grip even in deep sand and loose gravel. The engine hummed with a consistency that German mechanics found unsettling. They were accustomed to coaxing performance from machines. Here they were merely observing. One senior engineer remarked quietly, "It operates as if it does not expect us to maintain it." For German tanks, maintenance was not optional. It was survival. For Sherman, it appeared to be an afterthought. When the Continental R975 radial engine was removed from the hull for examination, Kummersdorf technicians expected to find production shortcuts, stress fractures, or imprecise machining. What they found instead was a design philosophy fundamentally different from theirs. The radial engine, though derived from aviation technology, was tolerant to heat, adaptable to varying fuel quality, and resistant to dust and sand, three conditions German engines loathed. Cooling channels were broad, not narrow. Lubrication paths were straightforward, not optimized to the point of fragility. Access to key components was open, not hidden under layers of interconnected assemblies. The more they studied it, the more one uncomfortable truth emerged. This was not engineering for perfection. This was engineering for endurance. And endurance wins campaigns. Perhaps the most shocking discovery came from the Sherman's transmission. German tanks relied heavily on straight-cut gears, precise, strong, but unforgiving. They failed under stress, demanded perfect alignment, and punished drivers who shifted improperly. The Sherman used herringbone gears, a technology America had mass-produced for a decade. These gears distributed load smoothly across multiple teeth, reducing stress and allowing the gearbox to endure abuse German designs could not survive. A Kummersdorf transmission specialist wrote, "We do not manufacture these at scale. We do not have the capability." This was not a question of intelligence or knowledge. It was a question of industry, and America had it in abundance. Over weeks, the Sherman was driven relentlessly. Engineers recorded fuel consumption, gear shifting behavior, temperature fluctuations, wear patterns on tracks, and sprockets component stress accumulation. After every trial, they disassembled the tank, expecting to find deterioration. Instead, they found uniformity, parts wearing predictably, evenly, and far slower than comparable German vehicles. A comparison was made with Panther early prototypes. It was devastating. Panther transmissions overheated. Final drives shook under stress. Engines strained at medium slopes. Crews had to be specially trained to avoid damaging the vehicle. Sherman? It simply performed. By June, the engineers had run out of ways to break it quickly. On June 6th and 7th, 1943, Albert Speer visited Kummersdorf for a major armaments conference. High-ranking officers, industrial leaders, and engineers assembled for demonstrations of German and captured Allied tanks. Panther stood proudly, a symbol of Germany's determination. Tiger loomed like a steel monument. Ferdinand represented the cutting edge of engineering ambition, and beside them sat the Sherman, modest, unassuming, foreign. Speer watched the slope trials closely. Sherman climbed cleanly, shifting gears fluidly, maintaining steady engine output all the way up. The driver, unfamiliar with the tank until days earlier, handled it without visible strain. The Panther followed, powerful but nervous, its gearbox hesitating at mid-slope, its engine roaring loudly just to match Sherman's quiet confidence. Then came the Ferdinand. Its massive weight and experimental electric transmission failed spectacularly halfway up the incline. In front of dozens of officers, it stalled. The embarrassment was unmistakable. Sherman was not supposed to outperform Germany's finest. Yet here it was, quiet, steady, reliable. Weeks later, Speer wrote an article in Das Reich praising Sherman's manufacturing quality. He worded it carefully for propaganda purposes. But his internal communications told another story, one of alarm. He had witnessed the terrifying contrast, German engineering brilliance versus American industrial maturity. Germany built masterpieces, America built dependable machines by the tens of thousands. Speer knew the war had shifted. German engineers could not replicate what the Americans created because Germany lacked the casting capacity, the automotive manufacturing depth, the standardized tooling, and the spare parts logistics. Sherman worked because it embraced automotive logic over military perfection, and slowly even the most stubborn engineers in Kummersdorf began to accept an uncomfortable truth. They had underestimated the Americans, and they had overestimated themselves. Through summer and autumn 1943, extended-range tests began. Sherman vehicles were pushed to extremes, multi-day endurance runs, heat cycling, rapid stop sequences, varied terrain marches, high-load stress trials. The final reports were undeniable. M4 variants routinely exceeded 2,000 kilometers before requiring major maintenance. Early Panther variants often failed within 100 to 150 kilometers. Sherman's gearbox maintained consistent efficiency under load. Panthers lost reliability rapidly when shifted frequently. Sherman's final drives almost never failed. Panther final drives failed catastrophically and repeatedly. One engineer wrote, "The American tank is not exceptional in any single category, but its reliability invalidates nearly all of our design assumptions." That sentence circulated quietly among Germany's technical staff. No one dared speak it aloud in meetings, but everyone felt its weight. By late 1943, the turning point had arrived. The crisis was no longer technical, it was philosophical. German armored doctrine prioritized power, armor, peak performance, and technical sophistication. American doctrine prioritized availability, sustainability, speed of production, and field reparability. One Panther engineer summarized the problem. "We built for excellence. They built for war." Sherman proved that a tank that reached the battlefield was worth more than a tank that impressed on paper. And as Kummersdorf closed out its year of testing, the engineers quietly understood. The war for armored dominance was not won through brilliance. It was won through endurance. And endurance was something the Sherman possessed in abundance. By late 1943 and early 1944, the German armored force was no longer fighting only the Allies. It was fighting itself, fighting the mechanical failures that stalked them more relentlessly than enemy fire. A tank crewman could outmaneuver a Sherman, outshoot a T-34, or outfight an American infantry battalion. But he could not outfight a broken transmission or a destroyed final drive. At the front, the nightmare began with a simple sound, a grinding noise beneath the floor, a vibration spreading through the hull, a sudden loss of torque. Every German tanker knew the feeling. It meant the machine was failing, sometimes fatally. And more often than not, it happened before the enemy fired a single shot. Letters from the Eastern Front recorded the same bitter sentiment: "We fear our machines more than the Russians." No battlefield, Kursk, Italy, Normandy, the Baltic, the Ardennes, escaped the curse. Sherman would prove its worth not through armor or firepower, but through the suffering it spared its own crews. German tanks inflicted suffering on their own men long before battle even began. The frozen plains of the Soviet Union punished every machine without mercy. Steel cracked, oil thickened, engines suffocated in snow. But among all vehicles, Panther suffered the most. In January 1944, one battalion recorded only 16% of Panthers were operational during combat days. Over 60% were immobilized by mechanical failures. Final drives destroyed themselves in deep snow and thick mud. Gearboxes resisted shifting once temperatures dropped. Engines overheated despite freezing winter air. All of this occurred before engaging the Red Army. Sherman, by comparison, performed far better under similar conditions on the Italian front and later in France. Its engine rarely choked in cold. Its oil filtration was robust. Its simple gearbox allowed drivers to keep moving even with limited training. German crews hardened by combat began resentfully respecting the tank they once mocked. The Sherman always runs. Our Panthers choose when they wish to run. If there was a single component that broke German morale, it was the final drive. Panther inherited its design from Tiger, and Tiger inherited a design philosophy from pre-war prototypes that were never meant to carry 45 tons of armor. Under stress, straight-cut gears sheared themselves to pieces. Bolts stretched and snapped. Bearings overheated. Lubrication systems starved. Casing fractured like porcelain. Crews learned its weakness the hard way. Turning sharply in reverse destroyed the gears. Pivot turning on uneven ground snapped teeth. Moving long distances on roads caused overheating. Hitting obstacles at speed misaligned the shaft. Manuals warned, "Do not shift into third unless absolutely necessary." A tank that feared its own gears was not a weapon. It was a liability. Sherman's herringbone final drives, by contrast, showed almost absurd resilience. Even decades later, restorers found them functioning perfectly after years in storage. It was as if the American machine had been built with the future in mind. German mechanics wrote bitterly, "We do not fail in battle. We fail before battle." Behind every German tank battalion was an army of mechanics, men who fought a different war. Their hands were blackened with grease, burned by overheated components, cut by broken gears. They toiled night after night, knowing that the same vehicle they revived today might die again tomorrow. Many Panther battalions required 20 mechanics for every 10 tanks, spare parts that factories could no longer provide, the hours to remove transmissions that Shermans could swap in minutes, specialized machine tools unavailable in the field, expert craftsmen, precisely the workers Germany was losing to military conscription. As the war dragged on, Germany's technical backbone eroded. Engineers at MAN, Maybach, Henschel, and Krupp begged for design simplifications. They were ignored. Sherman, meanwhile, embraced the opposite philosophy from the start. Simple tools, easy access components, interchangeable parts, standardized fittings, forgiving tolerances, automotive logic, modularity above sophistication. This was the core difference, and it was lethal. Additional captured Shermans arrived throughout 1943 and 1944, from Italy, from North Africa, from the Eastern Front. Some were American-built, others were British-modified. The Firefly variant, equipped with a 17-pounder gun, shocked German engineers for a different reason. When they attempted to fit the gun onto the Sherman's chassis, it worked with minimal changes. When they tried to imagine mounting such a gun on Panther, it required redesigning the turret ring, and the upper hull. Sherman had growth potential. Panther did not. Germany's most ambitious armored vehicle could not evolve without collapsing under its own weight. Sherman continued to evolve easily. Longer guns, new engines, better radios, improved optics, heavier armor, new turrets. One engineer muttered, "They build a machine with a future. We built machines with limits." Through late 1943 and early 1944, Kummersdorf conducted brutal reliability tests. Shermans were driven for hundreds of kilometers without rest. Engineers recorded every mechanical incident. The results were consistent. Shermans could operate for 2,000 kilometers before major failures. Early Panthers often failed within 150 kilometers. Even improved Panthers rarely surpassed 700 to 1,000 kilometers. Tiger I engines frequently required valve adjustments every 60 to 100 kilometers. Tiger II transmissions overheated during long marches. And then came the statistics that crushed German morale. Panther operational readiness in 1943 to 1944 often fell below 40%. Some battalions reported 20 to 25% readiness during critical operations. Meanwhile, Sherman units across all theaters maintained 80 to 90% readiness, repaired broken tanks, quickly used spare parts freely across variants and factories, continued advancing even after weeks of heavy fighting. The truth struck German command with brutal clarity. Sherman did not win through power. It won by always being present. Presence is victory in mechanized war. Absence is defeat. As the war worsened for Germany, captured Shermans were pressed into service. These were not modified like Soviet T-34s. They required no redesign, no retrofits, no Germanization. They simply worked. Crews wrote reports describing their experience in engines started reliably in cold weather. Transmissions tolerated rough shifting, tracks resisted jamming. Spare parts could be improvised. Visibility from the turret surpassed German designs. Internal layout reduced crew fatigue. The comment repeated again and again. With Sherman, we worry about the enemy. With Panther, we worry about the machine. For a fighting vehicle, there is no greater condemnation. In January 1945, during the desperate German counteroffensive in Alsace, the 10th SS Panzer Division captured 12 M4A3 Shermans. They were folded into the 13th Company and sent straight into frontline service. These Shermans became reconnaissance assets, rapid response forces, mobile reserves. They perform with astonishing reliability, even as German-made tanks collapsed under winter stress. Crews confirmed no catastrophic failures, no final drive destruction, no transmission seizures, no overheating despite heavy use. At the same moment, a nearby Panther battalion lost over 18 tanks in 72 hours, none to American fire, all to mechanical failure. Sherman succeeded simply because it behaved like a soldier's machine, obedient, predictable, durable. The opposite of Germany's own creations. By early 1945, German armored forces were exhausted, not by the enemy, but by their own machines. Panther and Tiger crews fought heroically, but machinery does not respond to heroism. Sherman represented everything Germany needed, but never prioritized reliability, mass production, industrial maturity, standardized logistics, mechanical forgiveness. War Daddy 2, just one tank among 49,324, was not a legend by design. It was a legend by consequence. It revealed a truth that German engineers never wanted to face. In mechanized warfare, a weapon that always works is stronger than a weapon that works only when conditions are perfect. In early 1945, under the bitter cold of a collapsing empire, the proving ground at Kummersdorf was no longer a place of innovation. It had become a vault of fading hope. The distant thunder of Soviet artillery echoed across the forests south of Berlin, shaking windows and reminding the engineers that time itself was evacuating the facility faster than they could. Inside the workshops, men worked under dim yellow bulbs, their breath turning to fog as they packed documents into crates. These were the final technical reports of the German armored program, years of work distilled into stacks of paper. Yet among the blueprints of Tiger II, Panther OSFG upgrades, and concepts for future E-Series heavy tanks, the files protected most carefully belonged not to a German machine, but to an American one. War Daddy II, a captured Sherman, once dismissed as a crude foreign curiosity, had become the subject Germany could least afford to lose, not because it held secrets of American firepower, but because it revealed the painful limits of German engineering. It showed them what they had overlooked and what they could never fix in time. In a storage hall on the eastern side of Kummersdorf, two Shermans, War Daddy II and another M4A2 captured in Italy, were rolled out for one final inspection. Not for testing. Those days were gone. These tanks were being evaluated for combat. Germany was desperate. Panther battalions were crippled by shortages. Tiger units had become immobile monuments to wasted potential. Tiger II vehicles could barely move on muddy roads. The overall readiness of German armored units had collapsed to a fraction of their theoretical strength. Amid this chaos, American-built tanks, once ignored, were now the most reliable machines available. A senior engineer from MAN paused as he passed War Daddy II, brushing dust from its cast hull. He whispered, "If we had 10,000 of these, the war would look very different." No one answered. No one needed to. From 1944 onward, the German tank industry suffered a catastrophic decline. The Maybach engine plants were destroyed. ZF transmission factories were bombed to ruins. Krupp's facilities operated only intermittently. MAN could no longer maintain its workforce. And worse, the country's skilled labor had been stripped away by endless mobilization. Factories were forced to rely on slave labor, workers with no training, no motivation, and every reason to sabotage German production. Reports became grimly repetitive: valve clearances set incorrectly, filters stuffed with debris, gear housings misaligned, engines failing straight off the assembly line. Panthers arrived at the front with hidden defects. Tiger IIs left factories already weakened by poor metallurgy. Even Panzer IVs, Germany's most mature design, began failing at unprecedented rates. One engineer summarized the disaster: "We no longer manufacture tanks. We assemble whatever parts survive." By 1945, reports from the field showed a brutal pattern. 70% of Panther losses came from mechanical breakdown, not enemy fire. Tiger II units abandoned their tanks during retreats because engines died. Tiger I turrets froze at slight angles due to hydraulic failure. Jag Panthers stalled on inclines. Panzer IVs overheated during sustained marches. A commander wrote bitterly, "The Russians do not defeat our tanks. Our tanks defeat us before we reach the enemy." In contrast, Sherman tanks used by American, British, and even German crews told another story. Engines ran in heat and cold. Transmissions tolerated rough handling, Spare parts were easy to swap. Breakdowns were rare and simple to repair. Field mechanics praised their accessibility. The same conclusion appeared repeatedly in German field logs. Sherman is not a superior tank. It is a dependable tank. And dependability wins wars. In January 1945, during Operation Nordwind, the 10th SS Panzer Division captured 12 intact M4A3 Shermans. Within days, they were pressed into combat. These Shermans became reconnaissance vehicles, rapid response armor, mobile reserves during crises. Their performance shocked German officers. No major failures, stable engines in freezing conditions, consistent transmission behavior, reliable movement during long marches. At the same time, a nearby Panther battalion abandoned 18 tanks in 72 hours, all due to mechanical failure. A German sergeant watching a captured Sherman drive past a dead Tiger muttered, "Perhaps God favors the simple machine." Tiger II was Germany's armored masterpiece, magnificent, powerful, and doomed. At 69 tons, it overwhelmed its own powertrain. The HL-230 engine was insufficient. Gearboxes overheated, torsion bars cracked under stress. Final drives shattered under sudden turns. Fuel consumption made movement impossible. Tiger II's flaws were so deeply embedded in its design that no late war fix could save it. The reason was simple. Germany built a tank to impress engineers. America built a tank to win a war. In a grim meeting of the Panzer Commission, the truth was finally spoken aloud. A devastating report recorded 500 failed final drives in Panzer IV, 370 in Panther, 100 in Tiger, 200 in Hetzer. General Wolfgang Thomall summarized the situation. Under these conditions, organized tank operations are impossible. It was the clearest, most brutal acknowledgement of failure the German armored force ever made. In April 1945, as the Red Army approached, chaos consumed Kummersdorf. Documents were burned or packed hurriedly. Prototypes were abandoned. Engineers fled or were reassigned to desperate defensive units. Yet in the final hours, 2 Shermans, War Daddy 2 among them, were fueled, inspected, and prepared for combat. A tired engineer laughed bitterly. "The American tanks will fight for Berlin. Our own tanks cannot make it out of the garage." It was the ultimate irony. The last tanks to leave Germany's greatest proving ground were not German at all. No record confirms what happened to War Daddy 2 next. It likely fell in the fighting or was abandoned when fuel disappeared, but its significance was already sealed. It had revealed the truth, and that truth could not be destroyed by artillery or fire. Years later, as West Germany rebuilt under the Bundeswehr, engineers revisited wartime data. Among thousands of captured documents, the Sherman files stood out. The Leopard 1, Germany's first main battle tank after the war, did not inherit its philosophy from Tiger, Panther, or E-Series dreams. Its DNA came from the lessons Sherman taught Germany: reliability over perfection, maintainability over complexity, industrial scalability over elite craftsmanship, accessible components over precision fragility, long-term growth potential over immediate specifications. A German engineer later reflected, "The Sherman was not the best tank of the war, but it taught us how to build the best tanks for the next century." War Daddy 2 was one tank among tens of thousands. Nothing about its design was glamorous. Nothing about its specifications was shocking. But it represented something far greater: the triumph of industrial maturity, the victory of pragmatism over obsession, the power of reliability over theoretical superiority. Panther and Tiger were magnificent failures. Sherman was a practical success, and practical success is the foundation of victory. Across North Africa, Italy, France, the Ardennes, and Germany itself, one truth became undeniable. A tank that reaches the battlefield is worth more than a tank that dies on the way. Sherman was not superior in armor. Sherman was not superior in firepower. Sherman was superior in the one quality that decides modern war. It kept moving. Every kilometer it survived was a wound to German engineering pride. Every hour it operated was a reminder of what Germany lacked. Every day it outlasted Panther, and Tiger was proof that the war had already been decided long before Allied tanks crossed the Rhine. WW2 was not legendary for its victories. It was legendary for what it revealed. Germany had already lost the industrial war. Sherman merely made that truth impossible to ignore.